Record. All right, we're recording. All right, hello for those who joined us on the YouTube channel. Please smash that like button, hit the subscribe, and turn on post notifications. We're
We
gonna get
almost
started with
we're
this.
almost hitting double-digit subscribers.
All right, this works. All right, so a rightward force is applied to a 6 kg object. Oh, there's someone in the waiting room. All right, back to talking. A rightward force is applied to a 6 kg object to move it across a rough surface at constant velocity. The object encounters 15 newtons of frictional force. Determine the gravitational force, normal force, net force, and applied force, and neglect air resistance. So we're going to draw the G. So our givens, we have mass. We have mass of the object. It's 6 kg. So we have 6 kg. It's so hard to do this. And then the object encounters 15 newtons of frictional force. So we know F of F equals 15 newtons. So what we're gonna do is we're gonna draw a little like dot, like she does in class. So we're gonna draw a little dot, and okay, a rightward force is applied to a 6 kg object. So I wrote it like that way.
Wait, Andrew, do you mind zooming in a bit, like onto your screen?
1 second. I need to like that.
Yeah, I mean, like to fit the screen. Yeah.
1 second.
Yeah.
That work?
Thanks.
That works, yeah.
All right, great. Now I have to delete all that. All right, back to drawing. And draw. All right, there we go. So givens, we got 6 kg, which is mass. We got F of F, which is force of friction equals 15 newtons. Friction always goes against the weights being pushed. So I'm going to draw a little dot, like so. So we know there's going to be a frictional force, so something going against it, which is our F of F. Then we know there's an applied force going rightward, which is our F of A. Oh my gosh. Sorry for doing this. And then we have our y's. So our F of G and our F of N. So we're just going to find F of G and F of N because it's the easiest. Let me just look. So F of G, to find F of G, so we're looking for F of G, F of N, the total force for Y and X, and F of A right here. So we got to find all four of them. So we're going to find F of G first. So F of G equals mass times acceleration y.
You kind of went a little quiet there.
F of G equals mass times acceleration y. So F of G, what's the acceleration for gravity?
Negative 9.8.
Yes, and what's our mass?
6.
6. So
Six.
6 times negative 9.8. Put that into your calculators. There's a dot right there. 6 times negative 9.8. You get negative 58.8, right? So F of G equals 58.8. Negative 58.8. Does that make sense to everybody? Cool.
Well, because it's weight, wouldn't it just be positive? 58?
Yeah, it would just be positive.
Yeah.
F of G is, yeah. And so if it says it's balanced on the y front, right? He's pushing it. Nothing is being acted upon going up or going down. So what would F of N be? If F of G is 58.8 going down, what would F of N be?
58.8.
Yes, it would be 58.8. So we got F of N equals 58.8 newtons. That is ugly as hell. So they cancel out. So we found F of G and we found F of N. Now we just need to find net force and applied force. Now one thing you guys need to read is it says a constant velocity. If it's a constant velocity, what is acceleration? If something's moving at a constant rate of speed, what is acceleration?
0.
0.
0. So your acceleration for the x is going to be 0. So a of x equals 0. So then you can use the formula, the sum of f of x equals mass times acceleration, right? Come on.
Yeah.
Yeah, that makes sense. Yeah, acceleration of x. So let's find this. We already have one of them, which is 15 newtons. So 15 newtons plus we're gonna name it x. Variable x equals our mass. What's our mass?
6.
6. What's our acceleration?
0.
0. So this is 0, right? These two equal 0. So 0 equals 15n plus x. What would x be? Come on. Y'all are smart. What's x?
Negative 15.
Negative 15, but you would write it as 15 newtons. It's one of those
Correct.
problems where like it says it's negative, but you write it as 15 newtons because it makes sense like that.
Because it's f of a. It has to be positive.
Yeah, f of a equals 15 newtons. Now we got applied force. So we can mark that off. Now we need to find net force. So we need to find like the sigma, the sum of. So f of the total of f of y equals what? How many newtons is it going up or down? Is it going up or down at all? Is it doing anything?
No.
Does it go up? Does it go down? No, so it's balanced, right? So it's, well, wait, I said that was wrong. But it's 0 newtons because 58.8 f of g cancels out f of n, right? They cancel each other out. What about the sum of f of x? Do they cancel each other out? Do they add? What do they do?
They become 30.
What's the net force of it?
30.
Give me 1 second. Wait,
Yeah, dude, it's just
my
15
brain's
plus 15.
putting tricks. Because if that's 30, then wouldn't this be like?
Wait, okay, now I'm
Wouldn't
confused.
that be 117.6? Let me think. Net force 30.
Don't you have to calculate for?
We have to calculate friction and f of a.
Wait, what are you confused about?
Wait,
I
did you
kind of
give
lost
us
you for a sec.
did she give us mu or
No,
the
she didn't.
actual
We
frequency
didn't get
force?
mu. She just gave us frictional force. I'm sorry,
Okay.
Mira. My brain's getting a little farty.
No, wait. Like, what's happening? Like, where are you confused of?
Net force. Do I add them or are they just 0?
The net force in the x direction would be 0, right?
Yeah. It would be 0.
Yeah. I think
15
that's
minutes
it.
pulling to the left, 15 minutes to the right. It's 0.
Yeah, exactly.
Sorry.
I think you just do the force of x equals 0. Yeah.
Yeah. So this would be the answer. You would of course write it out a lot nicer than mine. You would write it out in a sentence. Unless it's the test, then you'll answer it multiple choice or however she has it.
Wait, Andrew. Oh wait, Lois, do you want to go first?
No, you can go ahead.
Okay. I was just wondering, why was the normal force 58.8 again? Was it because
58.8.
yeah,
The
normal force.
an f of n because
Yeah.
f of g equals 58.8. So if it's going down, you're being pushed down by gravity 58.8, then how much does the ground have to support? Has to support the
Equal
same
amount.
amount.
Yeah.
So it equals it.
But I remember her saying that it doesn't always equal it. Is there like a criteria for?
Because it's not moving in the y direction.
It's
And we're only focusing on the x direction, so it would be y. I mean, it would be 0 for the y forces.
Okay.
what she said.
Okay, got it.
Anyone have any questions?
Is it unbalanced in the x direction? It is, right?
It's balanced.
It's balanced.
Yeah.
Okay.
It's
because
not moving at
zero.
all.
Yeah.
The
No,
way
it is moving. It's at a constant velocity though.
yeah, but
Yeah, so it's still balanced because it's
Yeah.
at 0.
if it's at constant velocity, it's a balanced force.
Yeah.
That's what I looked that up. I looked it up. I answered Alan's question like that like yesterday. If it says it's at a constant velocity, it is balanced. So moving on to question 12. Anyone have any questions about that one? No? Cool. All right, 12. All right. A 150 kg box of puppies is pushed along the ground with a force of 30 newtons to the right and another force of 15 newtons to the left. What is the acceleration of the box? All right, let me just think about this. So we're going to do Miss Kelly's way, givens. What do we have? What are our givens?
We have the
150
mass.
kgs.
Yeah.
150 kg is our mass, yes. All right, well, that's another given.
The net force is 15 to the right.
Yes, but we should, I'm just going to find there's two f of a's. There's f of a to the right. We're going to just say f of a equals 30 newtons right. And then another f of a of 15 newtons to the left. So our sum of f of a's equal 15 newtons to the right. It's hard to do this with a mouse, as you can see. Anyways, so what we're trying to find, what is the acceleration of the box? So we're looking for a of x. A of x is what we're looking for. All right. So let me think. So it's sum of forces of x equals mass times acceleration, right? So we have mass. Mass is 150 times a of x. And then we have sum of forces. Wait, let me think about this. You can't, Mira, you can't
Yeah, what's up?
find, there's no f of f, is there? There's no friction?
Okay, so basically when there's two applied forces in each direction, I make the applied force to the left negative.
Yeah.
So like that would basically act as friction
Yeah,
force.
I'm just, okay, so there's no friction really force, so.
Yeah, there's basically no friction force.
All right, yeah, because I didn't get no mu.
Yeah.
So 15 newtons equals 150 times a of x. If we wanted to do this Miss Kelly's way, we would do it beforehand. We would say f of x equals m times ax. Isolate the variable. I think I'm doing, yeah. Divide that by both sides. So the sum of f of x over mass equals acceleration of x. So 15 over 150 equals our acceleration. So we do that real quick. 15 divided by 150 equals 0.1. So the puppies are moving 0.1 meters per second squared. And I say, just to be safe, I say 0.1 meters per second squared to the right to give a direction. Rightwards or something like that. I would give direction just in case. Doesn't hurt. Anyone have any questions about that one? No questions? No questions? Going once? Going twice? Cool.
So do we not have to find like the y direction of it?
No, it's asking what is acceleration of the box. Y is balanced. Y
Just
equals
push it
0.
along so you don't have to find acceleration for the y's.
Y is balanced anyways. Y is 0. Acceleration would be 0 on the y anyway. So we're just gonna delete that. Delete that. All right. No more questions for that one. Can I move on?
Wait. So the free body diagram for that one would be there wouldn't be friction force, right? It would just be applied force on both sides.
Yeah, it would look like this. I should, but I'll do it for the next one.
You really should draw your FBDs.
It's because I did the first two questions by myself already. It would look like this. Of course, you would have the f of g and f of n right here, but we're not looking at that. We're just looking at this one and this one. Any questions?
Lois, for me, you know how friction force is negative?
Yeah.
So like since the applied force is going in the left direction, I would make that value negative. So on the FBD, I would say the f of a going in the left direction is negative 15 newtons.
Okay.
All right. Any more questions for that one? I'm just trying to pull up something that Miss Kelly sent me. I'm applying an upward force 15. All right. It's just I emailed her about this question 13 because it's one of those questions. All right. Miss Kelly Cat has a toy that hangs on the end of a string. So we have a string. If the toy has a mass of 24 kg and Miss Kelly pulls it upward with a force of 15 newtons, what is the acceleration of the toy? So now we're looking for A of y. And our givens are 0.4 kg, which is just enough to figure out what's going on. So our FBD, our free body thingy majiggy, would look like this. One going up, one going down, and another one going up. Bigger one. So this would be f of g. The bottom one would be f of g. And since this is tension, this has a string that hangs on the end of a string, that would be f of a. F of a is also tension. And then we also have another f of a right here, which is applying force upwards. So I'm going to find f of g so we can find this f of a. So we can figure out like the total. So f of g equals mass times acceleration downwards. So blah blah blah, I made a mistake, I'm a little tired. Equals 0.4 times negative 9.8. Y'all do that, tell me the answer, what you get.
Negative 3.92.
God damn it, Zach.
I'm sorry, man. I didn't mean it.
0.4 times negative 9.8. It is negative 3.92. So we know f of g equals, well, really equals equals 3.92 newtons going downwards. I guess you could put negative. So that means this tension right here, which was holding it, equals, we'll label this as 1. We'll label this as 2. F of A of 1 equals 3.92 newtons. If the toy has a mass, I'm not pulling it up. Okay, and then she says she applies a force of 15 newtons. So pretty sure she means it like she's applying 15 newtons. I'm a little confused on this question because
Wait, Andrew, remember when we did the
yeah,
force
that's what I'm
problems
thinking.
for class? Like number 3, it was the one with the cat toy. I think
Yeah.
it's like that. So I think the applied force would be 15 newtons and like up.
Minus 3.92, right?
Yeah. That's what I did.
I'm trying to think because I emailed her and she said I'm applying an upward force of 15 newtons.
Yeah, no. Looking at number 3, that's what I did. So it would be negative 3.992 plus 15, or that works too, equals 0.4 AY. So you would divide, like, since you would get 11.08, and then you would divide that by mass, 0.4. So I got 27.7.
All right. Let me just think about this. So that equals f of g plus f of a. Of course, we'll have to make that connected. All right. So it's going up a total of 15 newtons. She words these a little tricky. So your total f of a, scratch all that, equals 15 newtons, right?
Yeah.
Yeah. So it would be 15 newtons plus negative 3.92 because it's going downwards. We're going to make it negative. That makes sense, right?
Yep.
Hype me up. So 15 minus 3.92 is 11.08. So 11.08 equals the mass, which is 0.4, times the acceleration. And if we're doing it her way, we would do exactly like how I said it. It would do negative sigma of f of y over mass equals acceleration. So 11.08 divided by 0.4 equals 27.7, which is the acceleration.
Yep, that's what I got.
That was a little tricky. If you have a question, please speak now.
Yeah, if this one's kind of confusing, if you refer to number 3 on the force problems we did for like that summative grade like the week before Thanksgiving break, that should help a bit.
Just
Anyone have
a
any?
Wait,
little
what was it again?
Okay,
What was,
yeah, there we go.
You
Wait,
can clear up the answer. It's kind of hard to see.
what was the
Uh,
answer again?
Yeah,
The
looking at the
answer's-
board is very
27.7.
confusing.
I'm sorry, guys. It's
So,
just I don't have a steady hand.
or is it 27 point what?
7.
7.
Tw-
What I
27.7.
did, like for number 12, I didn't do nearly as much work, but I still got the answer right. Like I knew that we had to find acceleration, right? So I just used the equation F equals mass times acceleration, and then I just divided mass on both sides. So its acceleration equals force divided by mass, and then I just divided 15 by 150, and I got 0.1. So whenever I tried to do that on the second question, it messed up the answer.
Repeat that again. Sorry, I wasn't following.
Okay, so on question number 12,
12. Yeah.
yeah. So I just used the equation F equals m times acceleration,
Yeah.
and then I divided force by mass because if you isolate
Yeah.
acceleration, and then I
Wait,
just
so wait, for number 13, what did you get for force? What was the value you got?
I got 37.5.
What
It's
were the
because
numbers that led you to that?
added 15 newtons to 3.92.
Yeah, so the mass of 0.4 divided by 15. Oh no, 15 divided by 0.4.
What
Because
did
So
you
the force-
it wouldn't be 15 divided by 0.4 because there's the f of g is negative 3.92. You need to subtract that from 15, which would get you 11.08, and then you would divide both sides by 0.4, which would get you 27.7. If that makes sense.
Oh right, okay.
Yeah.
So wait, how did you get negative 3.92 again?
So you know how we've been doing f of g, like to get f of g, it's mass times a of g.
Gotcha.
So that's how you do it. Yeah. So it'd be 0.4 times negative 9.8, and you'd get negative 3.92.
Okay. All right, that makes sense.
Okay, cool.
I'm just trying to make it a lot cleaner. Because Lois complaining about my handwriting.
Sorry.
Is that better? Can y'all understand that handwriting?
Yes, thank you.
Anyone else have any questions? That was a little tricky. I can explain it further if you guys want me to. No? You guys are all smart? Y'all are gonna get hundreds on this test?
Off topic, I have a question. Did anyone else do the rest of the review? How long did it take y'all?
I haven't done it.
Alright, I was
It
just
took me
curious.
like
45
40 minutes to do it. I did it in math,
Okay, that's not bad. Thanks.
I may
but I
a little
skipped
bit.
like some of the questions. So
Yeah, I haven't done 7 or 8. But it
I
took me
skipped
about
8
Yeah, I
and
covered
10. I
the
didn't want to read
definitions, but I
the.
don't
Yeah, I
think it's
haven't
long.
done 7 or 8 either.
Alright.
That should be
7?
easy though. You're just plugging in numbers and getting them back.
Wait, I'm pretty. 7 is the one from physics class, right?
I think.
Yeah.
What-
All right.
What'd you say?
That one you just plug in the. It's like the model thing that it uses is easy to use. Like you just have to change the mu value. That's all that it makes you do. It gives you everything else.
This doesn't look too bad. Alright. Anyone have any questions about 13, 12, or 11? Oh, this does not look fun. Okay. Lee is sledding with his friends when he becomes that word by one of his friends' comments. He exerts a rightward force of 9.13 on his 4.68 kg sled to accelerate it across the snow. If the acceleration of the sled is 0.18 meters per second, I think she meant squared, then what is the coefficient of friction between the sled and the snow? So we need to know that to find f of f equals, let me think real quick, equals mu times f of n, right?
Yep.
Yeah.
It's yeah, correct.
So he exerts rightward force of 9.13. Right, so we're gonna draw this out. So he puts the rightward force, which is that, which is f of a. Would that be f of a?
Or which direction? Yeah, no, that would be f of a. Yeah, 9.13.
That's correct.
Wait, because if the acceleration slows. Cause
Oh, you're right.
Because he's not like putting on the he's not applying it completely, right?
No, he is. He's exerting a rightward force, so it would be applied
And
in
there's
the
f
right
of
direction.
f. Then you got f of n. And you got f of g. So let's find f of g so we can find f of n. So f of g, Basil. How do we find f of g? Basil. Cool. 4.68, which is the mass of the sled,
Times
times
acceleration of gravity.
which is negative 9.8. So we're gonna do the math. 4.68 times negative
Negative
9.8.
45.865.
It is negative 45.864. 864. My handwriting is so bad. I'm sorry if y'all can't read that. And then, so f of n, f of g equals, okay, 45.864. So f of n equals 45.864. I tried to do that pretty nicely. It didn't work out. All right, so then we have f of a. F of a equals 9.13. A equals 9.13. This Zoom meeting will end in 10 minutes, by the way. So, f of a equals that. So we're gonna do sigma of f of x equals mass times acceleration, right? Hello?
Yeah, you're right.
Yeah, teachers feel like this sucks. All right, so 9.13 plus whatever f of f is equals, what's our mass of the sled? 4.68 times, we didn't find acceleration.
0.815.
Yeah,
No,
we
the
did.
acceleration is
It
given.
says it right there. 0.815. So multiply these two together and you get five. You get 3.8142. So 3.8142 equals this. Yeah, let me just clean that up a little bit. So a lot of people don't like my handwriting. So 9.13 plus f of f equals 3.8142. How do we figure that out? We,
Wait, Andrew, where did you get 3.8? Where did you get the number from?
from this
Yeah, he multiplied the
mass times
mass and the
acceleration,
acceleration.
Okay.
multiply this
Okay, got it.
by this. So let me just think real quick. I'm trying to think. Can't think. This is simple math. I can't think of it. Uh, sorry, brain fart.
Yeah, negative
Yeah,
5.3158.
yeah. I would subtract. What I would subtract both sides. Yes, I would subtract both sides by negative. Sorry. Brain fart. 0.8142, and you get. Let me just do that one. Minus this. You get 5.3158 for your f of f. So f of f equals negative 5.3158 because it just makes sense, right? Right, guys?
Yeah, that's what I got.
Yeah. So then we need to find the coefficient. So we need to find mu, right? Yeah. Wait, do we? Yeah. So in order to find mu, we'll use this formula up here. We already have f of n, which is right here, and we already have f of f, which is right here. So we're gonna isolate the variable because that's what we do as responsible teenagers. Cancel that out. F of n. Time to write this neatly. F of f over f of n equals the correlation of friction. So f of f, what do we get for f of f?
Negative 5.3. Oh, you got.
Sorry.
What do we get for f of n? Cool.
45.864.
864 for sure. Then equals mu. So do that math. 3158 divided by 45.864. Your answer would be negative 0.1159 something something something, but mu is always positive, so mu would equal 0.1159035.
I rounded it to 0.12.
Yeah, you'd actually round it to 0.116. Right? Yeah.
Really? Oh, he wants us to keep it to 3 after the decimal?
Either Sinha wants 3 or
Oh, it's Sinha who wants 3, Miss Kelly wants 2.
okay, so yeah, 0.12.
Wait, what did we get for friction force?
Friction force, we got negative
Negative.
5.3158 or 5.318. Negatives are a little weird.
Okay.
Anyone have any questions about that one?
Wait, I thought we were supposed to find the mu.
That is mu.
Okay.
You find mu with friction force and normal force.
So what's the final answer?
0.12 is mu. Mu equals 0.12. Any questions about that one? So we're all gonna get hundreds. I'm making this joke again because I'm running out of jokes.
Haha.
Man, I wish Renai was here. I would be laughing. All right, so that's it for the word problems. Anyone have any questions about the actual review? No,
Not really.
not really. Basil, Panus.
Wait, I'm still hung up on
Basil of
the
Kiss
last question.
You go over 9.
9.
9, yeah. That one looks like.
I can try to do 9.
Wait, what was your question?
No, so what was your question?
It's mu times f of n or plus f of n?
So friction force equals mu times f of n, right?
Okay.
And we already
Yeah.
have f of n, we already have f of a, we already have friction force, we
Yeah.
already have f of n. So we just do the
Yeah,
Kelly way and isolate first.
Yeah, I got it, Andrew.
You got it?
Thanks. Yeah.
Equals mu, and then okay, yeah, you get it. All right, what do you want, Charlie?
Never mind. Well, like I was gonna ask for like number 9, but isn't that one you just have to? Is that based on like the other one, or is it its own little thing?
Let me just look at it. Luke drops a question. Wait.
That one is on physics classroom. If you look up the question, physics classroom pops up. It gives you all the answers and it explains everything.
All right, I'll do that.
Know how to do it.
I don't think she's ever taught something like that.
We've never done a problem like this.
All right, so that is it for the YouTube channel. So everyone,
Sometimes she puts physics problems things on the test, so go through everything and know how to do it.
Bro,
Don't
this whole
forget to-
review is weird.
don't forget to hit the like and subscribe button, and follow us for post notifications by YouTube.